Assalamualaikum and greetings to everyone. My name is Nurul Aisyah binti Mama Adzman from AS 253. Cost-efficient oil and water separation using oleophilic polyurethane foam is my research project under supervision of chemist technologist Dr. Nazihah Ibrahim. Without further ado, let me introduce you about my study. Nowadays, oil pollution is an environmental disaster that frequently happens due to many reasons. Regarding to this issue, several mitigation movements from government and authorities have been applied to curb this problem. Based on Mokoba in his study in 2021, in situ burning, mechanical extraction, chemical dispersion, and solidifies are some of the common methods that have been implemented to solve this problem despite of their disadvantage that could create a secondary environmental issue. Looking into these problems, we need an effort to solve oil spills problem in efficient way with low-cost material. But how? These porous material have great efficiency in due to their super hydrophobic and super oleophilic behavior. For this matter, recycling used PUF might be the best idea to solve oil spills problem since it efficiently separates water and oil and it doesn't burn your pocket. So, the significance of this study is by understanding the effectiveness of PUF as an alternative oil removal tool, and the parameter study was optimized to maximize the absorption capacity. For objective, first activation of PUF from automotive or furniture waste and characterized by FTIR and SEM, and the second one is to evaluate the performance of PUF for removal of free oil and emulsified oil in water. Done with the introduction, let's move to the literature review. Okay, based on Dhaka and Chattopadhyay in their research in 2021, it stated that oil spills causes could be categorized into two, which are natural causes and anthropogenic causes. Then, anthropogenic causes could be further be classified into two, whether it's accidental or intentional. They also mentioned that oil spills could give many impacts to marine biodiversity, human society, and economic activities. In marine biodiversity, it increases the mortality rate of this organism and indirectly increasing the extinction rate. Then, it disrupts the growth and development of organisms due to mutation in their DNA. Furthermore, it also could cause respiratory irritation, inflammation, ulcers, or bleeding towards organism. For human society, it directly affects to clean up personnel with serious risk of health since they are always exposed to toxic oil component. Then it directly affect their mental health issues since pH, VOC, and PAH, which contain in oil, could cause neurological problems. Moreover, it also gives huge impact on economic activities. It causes a closure of business in marine food industry areas since the quality of the food are affected due to contamination of oil. Then, usually the cleaning operation leads to grounding of vessels, which create a secondary pollution. Moreover, it affects the tourism industry since it damages the cleanliness and the view near the coastal areas. Now, let's talk about PUF. Based on NTU's 2010, PU is formed by the addition of isocyanate and hydroxy group. To obtain a PUF in terms of cellular structure and global mechanical characteristic, it includes two basic reactions, which the reaction of isocyanate with water to give unstable carbonic acid and strongly exothermal decomposition of this acid. Reaction between isocyanate with water form a gas bubble or known as carbon dioxide or blowing gas. Due to the expansion of the blowing gas, the formation of PUF turns out like this figure, which the bubble expands until form a polyhydro cells. Then, let's move to the methodology. First step that I took for this study by preparing my PUF, the PUF was treated with ethanol overnight to remove any impurities and dry in a vacuum oven. Then proceed with structural characterization using FTIR and SEM as shown in figure. Next is absorption capacity test. Weak PUF was placed in a conical flask filled with 50 ml of diesel and shaking it for 45 minutes at 200 rpm. Then the PUF was extracted and drained for 5 minutes. After absorption, the PUF was weighed again and squeezed by hand to obtain the diesel absorbed. Then the amount of diesel extracted was weighed. Next agenda is batch studies, which involve contact time where we vary the contact period of PUF with diesel. Then proceed with agitation speed where the PUF was observed under 4 different speeds as shown in the slide. Lastly, for initial diesel concentration, PUF was immersed in 5 different concentrations of diesel. Those batch studies were observed using the same method and technique as in absorption capacity test. Then, further observation or reusability test. For this test, we use 2 different methods that differs in aspect of extraction of oil method as shown in this slide. This test also observed under the same method and technique in absorption capacity test by using all optimum parameters that have been observed in batch studies. To analyze data, we use formula of adsorption capacity and oil adsorption percentage. Furthermore, for result and discussion, let's take a close look on its physical properties. From the figure shown here, the PUF before treated and after treated with ethanol have no differences in terms of pore size, the softness, and the color of the foam. It shows that ethanol doesn't trade off the structure and the mechanical durability of the PUF. Then, here shows the structure of PU. It was identified as PU structure since it contains a molecular backbone that have a urethane group as enlightened in this figure. Then, for characterization using FTIR-ATR, the functional group present in the adsorbent were determined. From 3 samples of polyurethane as shown in this slide, it shows similar bands and peak where there are NH stretching, CO stretching, CN groups, and CH stretching. But there are a bit different between sample A and B, with sample C by looking at the CH stretching peaks on sample C are slightly higher due to the hydrocarbon contained in this cell. For SEM, we could see a clear difference between PUF before treated and after treated with ethanol. The open pores in PUF before treated with ethanol shows a white debris believed as a contaminant, while for after treated PUF, it shows clean and smooth backbone. Then from this observation, it shows that both pore diameter is mostly within 500 to 700 micrometer and are distributed uniformly across composed skeleton matrix. For performance of PUF for oil adsorption capacity, we observe the contact time, agitation speed, and initial decel concentration. By differing contact time on adsorption capacity test, the optimum rate observed was at 45 minutes with a value of 25.19 gram per gram adsorption capacity. Then, for agitation speed, the optimum rate of adsorption capacity is at 200 rpm with 21.78 gram per gram. Moreover, for initial decel concentration study, the optimal initial concentration is 10 gram per liter with percentage of adsorption at 85.3%. Lastly, the reusability test shows that method 2 are more effective since the adsorption capacity from cycle 1 to cycle 2 only drop a bit compared with the first method. But it is advisable that do not reuse the PUF since it is inadequate to remove all the residual of oil contained in foam. Then we have abundance of used PUF to be recycled. So, in conclusion, from this study, the highest oil adsorption percentage reached is 85.32%. Then from overall study, the optimum rate for PUF to absorb oil are 45 minutes with 200 rpm in 10 gram per liter diesel concentration. In addition, it is advised to use PUF once only for every cycle. Then I would like to recommend that we should modify PUF to compare between pristine and modified version performance in absorbing oil from water. Furthermore, we need to broaden the range of parameters in the aspect of temperature, water contact angle, and pH to overcome the study's limited readings. So that's all from me. Thank you.